We finished off with 40 and 42 on Friday, so we'll pick up there with 41. So when we look at any problem like this here, and this is going to be kind of a giveaway, is that whenever there's a variable in both exponents, or an exponent on either side, we know that we'll need to rewrite the bases are the same, or find out what's going to make the bases be the same and work from there. Now there's two main numbers that we can rewrite 5/12 and 1/8 into, because one of them is 2. But it would be nice if I could rewrite 5/12 as 8 to a power. So if we do 8 times 8, we do get 64. If we multiply it by 8 again, we get 512. So we could have rewritten as 5/12 as 2, or we can rewrite it as 8 to the third power. And this would be to the 5x minus 1. Now we can rewrite 1/8 as 8. We can move it from the denominator to the numerator. But it means the exponent is going to go from positive to negative. And since 8 wasn't to any exponent, it's just going to be to the -1. At this point here, we can multiply our exponents, so we can distribute the 3. 3 times 5x is going to be 15x. 3 times is -3. Here we can distribute the -1. -1 times 4 is going to be plus 4, and -1 times -x is going to give us positive x. So we're going to get x plus 4. I switched the order because we could say 4 plus x or x plus 4. Either one's going to give us the same thing. And since the bases are the same, 8 and 8, it means the exponents have to be the same as well. So 15x minus 3 is going to be the same as x plus 4. Any questions on how we got to this point here? Now we just need to solve for the value of x. So the first thing we can do is we can add 3. We can add 3 or subtract x, or if we want to do it as one step, we could do that as well. Because the 15x minus x is going to give us 14x. Those cancel. Those cancel. 4 plus 3 is. And last but not least, we can divide both sides by 14. Thus x is equal to 1/2. And that's it. Since the number is going back into an exponent, it really doesn't matter what the number eventually become. But if we did plug 1/2 back into the original problem, we would get the same thing on both sides. So here x is equal to 1/2. Any other questions on this one here? We can look at 43 next. So 2 times e to the x minus 7 is equal to 5. Here, the first thing we need to do is get e to the x by itself first. We need to get e by itself first. So the first thing we can do is add 7 to both sides. Minus 2e to the x is equal to 12. Then the next thing we can do is divide both sides by 2, telling us e to the x is equal to 6. And so we got e to the x by itself, which is what we wanted. Now we can go on and solve for x. What's the next thing we can do? We can apply ln to both sides. Because for this here, the x moves out front. And ln of e simplifies to 1. And 1 times x is just x. On the other side, we have ln of 6. Now, since x is by itself, we can type everything into the calculator, which is just ln of 6. And ln of 6 is 1.792 or 1.791759469. Either one works. If you ever are unsure of how to round it or how it's going to round to 3 places, just give me more. Give me more decimal places. I'll take it. Questions on this here? Any questions on what we did for this one here? Questions on 44 or 45? One of these that we want to look at, or both. Okay. So for 44, the first thing we want to do is get e by itself. So the first thing we can do is minus 9 from both sides, which will tell us that 6e to the 2x plus 1 is equal to 6. Then what can we do? Divide both sides by 6, telling us that e to the 2x plus 1 is equal to 1. Is e by itself? I mean, there's an exponent with e, yes? But is there anything being added to the e? Well, no. Is there anything being multiplied in front of the e? No. So the e is essentially by itself. We do have the 2x plus 1, but what we can do is I can apply the ln to both sides. And that 2x plus 1 in the exponent would move to the front, move in front of it, which will tell us that we have 2x plus 1, because ln of e simplifies to 1. So 2x plus 1 times 1 is just 2x plus 1. On the other side, we have the natural log of 1. Will the natural log of 1 simplify nicely? Most likely not, right? Because most of the natural logs or logs that we have don't simplify nicely. This one here, does it? It's 0, isn't it? Okay. In this case, it does. It actually works that log base b of log base b of 1 is always 0, no matter what the base is. Because as an exponential, we're saying b to the 0 is equal to 1. As long as the base isn't 0, this is always true. Now, we could have left it as ln of 1 and gotten to the same answer, or we could rewrite it as 0. Now the next thing we need to do is just solve for the value of x. So we can subtract 1, telling us 2x is equal to negative 1. Exactly. The last thing we'll do is divide by 2, telling us x is equal to negative a half. And that's it. Any questions on any of this here? $45. What would I do first? What would we do to both sides first? Huh? You're wanting to use ln? I mean, ln does work. ln of both sides would get us to the answer. Now, if I applied log base 7 to both sides, here we get log base 7 of 7 to the x. Well, the x would move out front. But log base 7 of 7 is 1. So this here is equal to log base 7 of 3. if we type this in a calculator and go math log base 7 of 3 and hit enter, we get 0.564575 going on. I'm going to do ln of 3 over ln of 7. We get the same thing. So either way works. 0.565. It just works out using log base 7s a little bit quicker. But especially when I was in college, I would use the LNs because it seemed like an easier method. But it will get you to the same answer. Questions on any of this here? And part of the reason this does give us the same answer is our change of base. B of x is equal to log of x over log of b, which is the same as ln of x over. So the natural log of 3 over the natural log of 7 is the same as log base 7 of 3. It's just our change of base formula. Any questions over any of this here? Questions over 46 or 47? Are the logs the same? Yes, so what's inside has to be the same as well. Let's get a nice, whatever this color is. Now the reason this works is really I could put both sides to the base of e, because e to the ln cancels, e to the ln cancels, leaving us with 3x plus 2 is equal to 4x minus 5. That's why this works. But our main property, especially when we covered it the first time, was if the logs are the same, what's inside equals. This is why. Because we hadn't gone over the fact that e to the ln simplifies out, cancels out. We had a little bit, but not in this fashion. Now at this point here, we just need to solve for the value of x. So we could minus 3x from both sides, telling us 2 is equal to x minus 5. Then we could add 5 to both sides, telling us x is equal to 7. And that's it. Questions on 46 or 47? We feel comfortable with these two here. Okay. If you do come back and have questions on 46, please ask. The other video does have it from 4th hour. Questions on 48 or 49? Are the logs the same? Yes, for both of these logs are the same, yes? So what's inside has to be the same as well. So for either one of these, so we can do 49, 12x minus 9 has to equal 3x. At this point here, we could subtract 12x from both sides, telling us negative 9 is equal to negative 9x. At this point here, we would divide both sides by negative 9, giving us x is equal to 1. And that's it. We would do the exact same thing for 48. Any other questions on this here? We're ready for the next ones. Let's go on and look at 50. So both logs are the exact same. We have log base 2 on both sides. So what's inside has to be equal. So we're saying that x squared minus x minus 6 has to equal negative x. At this point here, we can add x to both sides because negative x plus x is 0. Over here, we'll have x squared. Negative x plus x is 0. So it works out that our x term actually became 0 on both sides. Well, since we don't have a middle term anymore, we can use the square root method, which means I can add 6 to both sides, telling me x squared is equal to 6. And then we would square root both sides. So x is equal to plus or minus the square root of 6. I would leave it as this here. I would leave it as the square root of 6. Now this is different than the ones before because our logarithms, we can't write it as a nice square root of 6. As odd as that sounds, because square root of 6 is not a nice number. These here, I will take the square root of 6 because again, I've been taking the square root of 6 all year. I'm not going to change at this point here. But we do need to make sure to see which one works and which one doesn't. Which one do we think out of the positive square root of 6 and negative square root of 6, which one do we think would not work? Negative. So if I check it, log base 2 of negative square root of 6 squared minus negative square root of 6 minus 6 is equal to log base 2 of negative square root of 6. Let me get a highlighter. Now, for this first part here, I wouldn't use the log base 2 because, again, typing log base 2 is a little funky, a little tricky. I just mainly want to see what's inside. Because what's inside our log cannot be negative or 0, because if it's negative or 0, it doesn't work. We're mainly wanting what's inside the log to be positive. So we could type that all into the calculator. So I could say, parentheses, negative second square root 6, close parentheses, squared, minus negative second square root 6, close parentheses, minus 6. And if we type this all in, we get a negative number, yes? No, we got what? A positive number. Well, negative square root of 6 squared. Negative squared times square root is negative square root of 6. Well, the negative times the negative is a square root of 6 times square root of 6 is 6. In the middle, negative gives us plus square root of 6 minus 6. Well, these are gone, leaving us with just the positive. That works. Even though the square root of 6 is an ugly number, it's still, we have a positive number inside the square root. The other side, negative gives us positive square root of 6. So interestingly enough, for this problem here, negative square root of 6, it does work. Let's try it with positive square root of 6. So, eraser and just erase that, and all this here. Now, if we use positive square root of 6, my calligraphy pen back, 2, this would be the square root of 6 squared minus square root of 6 minus 6 is equal to negative square root of 6. Interestingly enough, for this one here, I don't even have to mess with the right-hand side. If we look at the left-hand side. If we look at the right-hand side, negative square root of 6 is going to be negative square root of 6. That's as simplified as what I can on the inside of that, yes? Can we have a negative inside the square root? No. So the positive case for this one here actually doesn't work. We want negative square root of 6 as the answer. If we'd simplified the other side, we would actually end up with log base 2 of negative square root of 6. It doesn't matter that they're the same thing on both sides because negative square root of 6 inside of a log does not work at this point here. So the answer has to be x is equal to negative square root of 6. Questions on these here? And again, on this one here, just plug x back in if you think one of them might not work and see, do we get a positive number or do we get a negative or 0? Because if we get negative or 0, it does not work. Any other questions on number 50? Questions on 51 or 52? Which one do we want to look at first? (51). So if I want to simplify the log, I'm going to apply both sides to the base of 7. 7 to the log base 7. We'll simplify out, telling us that 4x plus 9 is equal to 7 squared is 49. I mean, if we get a nice number, might as well just simplify it and write it. Because we didn't do it with most of the logs, because the log of anything or most numbers isn't a nice number. Now we just need to solve for the value of x. So the next thing we can do is we can subtract 9 from both sides, telling us that 4x is equal to 40. And then divide by 4, telling us x is equal to 10. And that's it. Any other questions on this here? We feel good with 51? Do we want to look at 52? So what would we do first? Put both sides to the base of e. E to the ln simplifies, telling me that 6x minus 2 is equal to, so is e to the 7th going to be a nice number? No, because e is not a nice number to begin with. It's an irrational number. So for this problem here, I'll leave it as e to the 7th. Because if it works out to be a nice number, might as well go on and simplify. If it doesn't, we'll leave it alone till the end. Now we just need to solve for the value of x. So the first thing we can do is add 2 to both sides, which will tell us that 6x is equal to e to the 7th plus, and last but not least, we would divide both sides by 6. Minus x is equal to e to the 7th plus 2 divided by 6. $183.1055 and I think the answer key point says 0.106. I will take either one. And if you don't feel comfortable typing these into the calculator, do make sure to give me this before you simplify it. But if you do feel comfortable enough seeing this all the way worked out to where, okay, I'm going to plus 2, divide by 6, and I have the e, and type it all in, that's fine. But I would make sure to give me this here just on the off chance you type it into the calculator wrong. Not saying that you would, but just in case, it's good to have it. Because if I look and see that, okay, whatever you put here is not right, it's way off, I'm going to look back to see what you did beforehand to see if you do have the right statement. Because it could be that you did have e to the 7th plus 2 divided by 6, but when you typed it in, you did like I sometimes do, and for the 7, I forgot to bump out of that exponent and put e to the 7 plus 2 divided by 6, which will give you a totally different answer. Any other questions on these here? Any other questions on 53 or 54? We good with 53 and 54? Questions on 50, let's do 56. Whenever we have two logs being added together, we're going to need to rewrite it as a single log. So we can rewrite it as a single log with what's inside being multiplied together. So our x times x minus 2 will be inside the log. Now we need to put both sides to the base of 2. Because 2 to the log base 2, these will cancel out, telling us that we have x times x minus 2 inside, or left over on the left-hand side. Now 2 to the 3rd, will that simplify easily or nicely? 8, it will. On the left-hand side, we do need to simplify this so we can distribute the x. X times x is x squared. Minus 2x is equal to 8. Since we do have a quadratic, we do need to get this equal to 0. We can subtract 8 from both sides, telling me that x squared minus 2x minus 8 is equal to 0. Any questions on how we got to this point here? Now at this point here we can factor. Since the 8 is negative, our signs are opposite. The only factors of x squared are x and x. Now we need to see the factors of 8. Well, we have 1 and 8, 2 and 4. We would want to use 2 and 4. Which one's positive? 2. The 4 is negative. And if we check this here, we would get a middle term of negative 2x. Whenever we have two or more things multiplied together to equal 0, one of them has to be 0. For x plus 2 equals 0, we can subtract 2 from both sides, telling us x is equal to negative 2. For the other one, we can add 4 to both sides, telling us x is equal to 4. This is what we started with. But in either place, do we have the ability to offset a negative when plugged into x? Well, no. Because if we plugged in negative 2, we would have log base 2 of negative 2 plus log base 2 of negative 2 minus 2, which gives us log base 2 of negative 2 plus log base 2 of negative 4. I have a negative in 2 spots, so that means negative 2 does not work. Small eraser. If we did the same thing with 4, well, this is still going to be just log base 2 of 4. 4 minus 2 is? They're positive in both places, so this one here works. So x equals 4 would work for this one here. Any other questions on 56? 55 would work in a similar method. You just have to use the quadratic formula to finish it up. And I believe none of the ones on the test are going to require the quadratic formula to solve. Let's look at the last set, 57 through 64. Do we want to look at either one of these here? 57 or 58? 58. So the log is less than 4. There's a good chance the restrictions might come into play. But the first thing we can do in solving for x is to put both sides to the base of 7. Because 7 to the log base 7 will simplify, leaving us with x plus 2 is less than. Will 7 to the 4th simplify nicely? It will. It is 2401. 7 to the 4th will simplify nicely. So we'll go on and simplify it. If it didn't, we would leave it alone till the end. Now what can we do next? Subtract 2 from both sides, telling us x is less than 2399. So x is less than 2,399. Now we did start out with a logarithm, yes? And what's inside a log cannot be 0 or negative. Is 0 less than 2,399? Yes. So would our restrictions come into play with this kind of solution? Well, yes. So inside the log is x plus 2. And what we know about logs, this has to be greater than 0. So all we need to do is solve for the value of x. So we can subtract 2 from both sides, telling us x is greater than -2. Which means over here we have to add that in, saying that the solution for this here, -2 is less than x is less than 2,399. You're welcome. And that's it. Now, if this had said greater than instead of less than, we don't need the restriction because 0 is not greater than 2,399. Now, whenever it's in an exponent, it really doesn't matter because the exponents can be positive, negative, or 0. We can have any number in an exponent. We can't have any number inside of a log. Any other questions on this here? Any questions on 57? Questions on 59 or 60? 59. So if we look at 59, the first thing we want to do is to get the natural log by itself first. So the first thing I would do is subtract 7 from both sides, because 7 minus 7 is 0, telling us 6 times the natural log of x is less than 53. The next thing we need to do in getting x by itself is divide both sides by 6. Because here 6 divided by 6 is 1, telling us the natural log of x is less than 53 divided by 6. Well, 53 does not divide by 6 evenly. So I will leave it alone. Now the next thing we need to do is to get x out of the log, which we can do by applying e to both sides. These will cancel out, telling us x is less than e to the 53rd divided by 6. 6,859.11. 112. Now again, x is less than it, and we're starting off with a log, yes? So our restrictions are going to come back into play. Well, the only thing in the log is x, and it has to be greater than. So here, 0 has to be less than x is less than 6,859.112. Any questions on this one here? Any questions on anything we've done so far? Questions on 60? Questions on 62? Well, I'll go on and do 62. To simplify this here, we're going to apply log base 3 to both sides. Because here we'll have log base 3 of 3 to the 4x minus 5 is greater than log base 3 of 108. Now on the left-hand side, we would move the 4x minus 5 out front, which leaves us with log base 3 of 3. And log base 3 of 3 is 1. So we're saying 4x minus 5 is greater than log base 3 of 108. I have a feeling log base 3 of 108 is not a nice number. It has a very big decimal, so we'll leave it alone. Now we just need to get the value of x by itself. So the first thing we can do is add 5 to both sides, telling us 4x is greater than log base 3 of 108 plus 5. And last but not least, we would need to divide both sides by 4, telling us x is greater than log base 3 of 108 plus 5 divided by 4, and that's not our bell. And at this point here, we could type this into the calculator. I believe you got 2.315, yes? Now, did we start out with a logarithm or an exponential? Was x inside a log or x in, it's in an exponential, yes? It's in the exponent. This is the answer. If we're in an exponent, it doesn't matter what x's inequality is. X could have been less than this, and it still works, because what's in an exponent can be positive, negative, or 0. Exponent can be whatever we want. The logarithms are the only ones we'll have the restrictions with. And we'll need the restrictions, or we'll know we'll need them, if we get all the way down to the end and its x is less than that amount and we started with the log. Then we'll need to add those restrictions in. Otherwise, we won't. Any other questions on any of this here? Okay. So we'll go on and